Hello everyone, welcome back to the channel. In the previous videos, we have seen how we can plot various shapefiles and rasters using simple codes in Python. If you have not yet seen those videos, you can find the link of the videos in the description. In this video, we will see how we can plot two datasets in a bar plot in Python, thereby able to compare both this data to have a relationship. So if you see here, this is the kind of image which we are trying to plot. So let's see how we can write the code for this kind of image in Python. So let's directly get into the video. So in order to start writing the code, first we will see what are the data sets which I have. So as you can see here, this is one of the data which I have, which is the slope data along a drainage network. So in a drainage network, let's say I have a drainage network like this, and I have points at each cell level to determine what are the various values along different locations in the drainage network. So like this, I have values at different cells, as you see here, at different distances from the starting point. I know the values of the slopes. In the same way, I have the data of rainfall at different cell locations, as we have seen earlier. So with this data set, I want to see along the drainage network how is the rainfall varying and what are the slopes, because I'm trying to understand the relationship between rainfall and slope to determine other elements like sediment transport, etc. So here in this video, we will plot with the rainfall data in the primary y-axis, and in the secondary y-axis we will have a slope. So to start that, let's directly go into Python, and we need to see, as we have the data sets in Excel, we need to be able to read the Excel data to be understanding this data and plot it. So to do that, one package which we need is pandas. So the first step is that we will import pandas as pd. So this is how you import the data, which is pandas. And now what I want to do now is load my Excel sheets into pandas. So to do load that, first I will name it as rainfall. And here already it is giving us a suggestion here that you can read the CS file like this. Here I am reading an Excel sheet, not CS file, so I can directly say Excel, as you see here, directly click it. So after this, you just paste your path of the Excel sheet where the data is stored. So I just pasted my path where my data is saved. So the next thing is we need to have our slope as well. So we will name it as df slope. Then already it is giving a suggestion. If you press tab, it already fills everything. So what we do is here we paste the slope path. This is the path where my slope is present, slope Excel sheet. So now once we have inputted the data, what I want to do, a simple thing, is to be able to combine these two into one data set so that I can access both at the same time to plot rainfall and its corresponding slope value. So assuming that these two data sets are of the same length, I will write a line. So as I said, I assume the data to be same length. If not, we need to interpolate or something. What I am doing in this line is I am combining my both Excel sheets with the common element present in them. So that is how this line is doing. What is it doing? It is going into the pandas because we need to access our Excel sheet using the pandas package. Then we are using the function concat. What it does, it tries to find we give what is the common column in rainfall and slope, and we join all the remaining data. So we will have one common column and all the other columns which are in both the data sets. So here my column is the cumulative distance. If you see in the Excel again here, I have the cumulative distance here, distance from the starting point which I'm believing it to be, and then I have the same one in the other one as well. So with this, what I'll do is I'll have these two slope and distances as well as rainfall and distance combined. So now I will have rainfall and slope in the same data. So that is what I'm saying here. I'm saying like what are the objectives, that I want to take this data as one column. Then in rainfall data I am taking fall, and in the slope I will be taking slope. So I have slope here saved, and in the other file I have it as rainfall. Let me just save this. Then if you see here this line, what it is doing is combining the data sets and giving us the df combined, which has all the components. So firstly, let's see if that is happening or not. I'm just saving as print, and I will put a debugging point here so that I can check it. So let's first check if our first step is correct or not. So if you see here, we got df combined, and we see it as a data frame. You can see here that I have the cumulative distance, I have the rainfall, and I have the slope. So with these three data sets already in, so now what we can do is we can just proceed to the next step, where we will be using our rainfall and slope and plot the data sets. So we can just cancel it because I'm not saving and I'm not interested in printing yet. So I'll just delete it instead, debug it. Now the first step is done. So in the next step, what I want to do is, because you need to determine what your x-axis and y-axis would be. In my x-axis, I want the number of locations, and in the y-axis, I want rainfall and slope. So to do that, first I need to know what are the total number of points in the x-axis. So to know the total number of points, as you can see here, I have put number data points, which is what I'm saying is the total number of points, and I'm finding the length of the data set. So it gives me the total number of rows. So this length would be the total number of values in the x-axis, and for each point I will know the rainfall and the slope values. Now what we need to do is we need to start preparing our figure so that we know that how we are asking the code to plot the figure. So to do that, the first step is we need to define the sizes of the figure as well as the axis details. So in order to start plotting, we need to use a function called plot, but to do so we need to import matplotlib. So what we will do is import matplotlib. So it is already suggesting, because I've already written plt here, it's suggesting there that you can use matplotlib.pyplot as plt. If you press tab, it fills the remaining details, and as you can see here that the package is loaded, and you can see that the red line before it was there like this. If you see the red line here, it means it is missing the name called plt. So now once we have it, it is not appearing anymore, and here what I'm defining is I'm asking it to make a plot of size 12 by 7. It will be 12 in the x-axis and 7 in the y-axis. That is the overall size of the plot which we'll be making it. So once we define how our figure should be and what are the axis details and stuff, the next thing is we start plotting our data in x and y axes. So as we have two axes, one primary axis and secondary axis, so what we will do here is we need to define in which axis am I plotting. So I'm saying in my axis 1, I want to have a bar plot, because as you've seen the figure earlier, I'm plotting a bar plot in x-axis and y-axis to be able to see how the precipitation is changing as well as how the slope is changing. So I'm saying I want a bar plot and I want to start from 0 to the length of the points which we have defined here. So to be able to determine that points, it needs to count the number of points and plot it. So here we need to import a package called numpy, which takes into these operations. Input numpy as np. So once we inputted the package, you can see we arrange our data from 0 to the highest value, which will be the total length which we calculate here. And then what do I want it to plot? So because this is my first axis, this is my primary axis, as you can see here. So I want it to plot the rainfall data set in my primary axis. So what I am saying here is going to DFP combined, and our rainfall value here is rainfall. So we just input that here and we say go to the combined value and plot the rainfall in the y-axis. We need to put dot values because if you don't put this, it is just going into the column and not doing anything. It just sees the column data, but now we need to plot it for each location. So we are saying go to this location and get the value and plot it. So that is what this defines. Now I want to have the rainfall data as one color and slope as another color. So I'm taking the color of the tab as blue. The whole tab would be blue and my plot also would be blue, and my label would be rainfall. So the label of the data is rainfall and it will be in blue color. So once we plotted it, we need to also think about, okay, I'm plotting the axis, what is the label, its size, and how should it look. So to do so, we will have to put our axis labels. So to set the label, we use this command where we say axis1 dot set x label, because initially I'm putting the axis of x and y because I already plotted my both y-axis data and x-axis in the statement here. So I want to label both. So I'm setting the value as number of points as its label, and I want to have a font size of 60. Once we set our x label, the next step is to set the label of our y-axis. So as you can see in here, like I just changed one element here, which is instead of x, I'm putting here y. So that changes the label to y label, and I want to name it as rainfall in mm. And as I already discussed, we'll put a color of tab blue here. So that is why we are specifying the color blue, and the font size again here is 16. So with this step, what did we achieve? We will have our plot in x and y labels and with our data sets in it. So once we have written it, we need to determine whether we are doing correct or not. So what I will do is I will plot the data to see whether what we are defining here is correct or not. So do so, we'll use plot.show, which gives us the plot. So if I just press run here, you can see that the figure is plotted with the rainfall in our y-axis and the number of points in the x-axis. So this is one component done. We already plotted our preliminary y-axis. We need to just plot our secondary axis and invert it so that we can see the slopes falling reverse and the rainfall in the general way. So to do so, our next step is we need to create a secondary axis first. To do so, we can remove this here because we are not interested in showing the plot there. So we put our secondary axis here. We create it as axis 2 because we are here already creating axis 1. What we will do is we'll say I want to create an axis which is similar to the axis which we created for a primary plot. So we'll just twin the plot as you see here. I'm saying axis 2 is twin of axis. We are just twinning the axis so that we have the axis in the right hand side. Because if you saw in the previous figure, which I will plot again, let's say we make it as a comment. So if you see here, we have our y-axis here. What I want to do is have another axis which is here, which represents the slope. To do so, I am twinning the axis as axis 2 here, and once we know that this is axis 2, now similar to what we have done here, we need to add the data set which we want to plot in axis 2. What I will do here is, because it's the same, let's first delete this, because it's just the same data set with different axes. I copy it and paste it here, and let's say I also add a comment. Let's do this, plotting the plot with plot index versus slope on the secondary axis. So it is same here, but instead of axis 1, we will have axis 2 and all the places. And the first step, it is same, like we arrange, because at each point in the x-axis we need the slope. So this remains the same, but in df command now, instead of rainfall, we need to have slope. So we will just replace it slope, and I don't want to have it blue because I want to show the differentiation between rainfall and the slope with different colors. So let's say I put it orange here, and my label would be slope. So that will be the first step. The only things we are changing is color of the bar and the slope values. So we can just delete it, because we already had our x label named in axis 1. So in the axis 2, we don't need to name it again. So we can just remove this here so that we don't get confused. This is how we plot in our secondary axis. So let's see how is it looking. We'll again say plt.show. We just run the plot to see whether it is coming correctly or not. So now you see two axes, rainfall and slope, but I could not see the slope label yet. So let's do one thing. The reason why we did not see it is, if you remember here, I put x label instead of y label, and also we can put the color bar there as well to say what color should we need here. I can change it to orange, and if I just run the plot again here, because I put x label here instead of y label, so if you see the result here, that we can see both the plots in the secondary axis as the primary axis. But my main motive is to have this plot in reverse coming down, so that I can understand for each location how is it related. Because if you see here, you can see the data, but I feel like if you can have a reverse plot here, it helps it more to understand easier. So to do so, what should we do now? In theory, we just need to say the code that you see the secondary axis, right? Make it reverse. That is the simple thing we need to tell the code. To do so, what we will do here is, we will say reverse secondary axis, because that is our main thing which we want to do. So what this line of the code is doing is, it is going into the y-axis, because it is setting the y-axis limits and saying that I want the y-axis to be inversed. That is what this line says. It goes into the y-axis and gets the y-axis limit and says that inverse the data. That is the simple thing which this line is saying. We just write it here and load it. Let's say, is it reversing? So if you see here, when I told the code to go and set the y-axis limit like inversed, so this is what it is doing. So you can clearly see the data is inversed. It is not wrong, because the peak values were in the left hand side, and even here it is in the left hand side, thereby gradually reducing. So this is the final step where we completed the inverse thing. Now all is left is to make it look better and easily understandable. To do so, what we can do is we can change the sizes of the labels, we can change even the colors here, and also increase the axes ticks so that you can see you don't see this bar which is touching here. If you see here, it's touching, so it creates an issue for us to be able to understand it better. So to do so, I want to increase this limits. It's 100 here, let's say I put it at 150, so the blue values come down, and if I increase it to 0.1 here, let's say, even these values go up so that you see it well. To do so, it's quite simple. You just ask the tick parameters to be changed. So how do we do the tick parameter change? First, let's change it of the secondary axis because we are already in this element. We need to do this element before we reverse it because it is easier that way. So what I did here is I'm putting the limits of my text in the secondary axis. So here I'm saying set my y-axis limits to 0 to 0.2. Saying like that is the starting, 0 is the starting point and 0.2 is the ending point. I'm saying adjust the limit so that it looks good. So if I run the plot here, you can see that it's looking good because I put it at 0.2. These values are like quite less and it has come above. The next important thing is I need to bring this down as well so that they don't overlap and I don't get the value correctly. So similar to what we have done for the second axis, we'll do the same thing for the primary axis. To do that, we just paste this line here. We will say set y-axis limits to 150. So if I run the plot here, it should give us the data. If you see, it has reduced down because this limits has increased, but it's still overlapping. So let's say I put it at 180 and run it again. Now you can see that they are not overlapping, but still you can understand the relationship here. So here the rainfall is 80 and the slope is 0.05. Assuming that 1% slope is like very high, this is meter by meter into 100. So a 5% slope with a rainfall of more than 80 mm can cause more sediment to move. Like this is one of the theoretical thing which we are trying to understand because that is the work I'm doing currently. So we can try to form a relationship with this because now we understand both slope and their relationships using one figure better. So all now it's left is to make it look good, have a title and also have a small legend. Firstly, what we will do here to make it look more better is change the sizes of the ticks, which you can do it with tick parameters. So this line, if we just minimize this is the line which changes the tick sizes and also it gives a color to our secondary axis. So what here I am doing, it's simple is I'm saying go to the secondary axis, go to the tick parameters, and for the axis Y, I want you to make it as orange with a label size of 14. If I just run it here, you can see it here that everything is changed into orange color with a size of 14, which makes it more clearer now that the slope values are the orange color and the rainfall values are blue. Similar to this, we can do it here as well, here using the same line. If I just minimize this, we go here and place it below the labels here and say it is axis 1, tick parameters with axis Y, and here the tab value is blue, and when I run this data, what I can see here is I should have blue values here which are rainfall corresponding to these data, slope values here are corresponding to this data. So all now it's left is having the title, and that's it. We are done with our results. To have the title, what we can simply do is we can say plot title, plt of title, and we remove this and put rainfall versus slope. We put the size of 20, so hoping that it looks good and better. So if you see the final figure here, we have our rainfall data and slope data which are plotted along correctly, and we also have our title. This is the final figure which we are trying to get: rainfall and slope, and also having inverted slope value representing slope at each location. Now we can just save the result with plt.savefigure, and you can say here that I'm saying at this location, let's say it is rainfall and slope for a branch of a river. I can just run it and we'll get the result here, and we'll see how it is saved so that we can get a good picture. We can also change the axis values here. So if you see the values are smaller, what we can do here is we can do the same thing what we did here for tick parameters by increasing the label. We can do the same thing here, like adjusting the tick sizes of x-axis to 14 value. If I run the data here, I hope you see here that the sizes are bigger, and also I want to have the grid lines so that I understand this data better. So to do so, what we can do here is we can just put grid line as true. So after this data, what I will do is I will say axis 1 grid line as true. So if I run the data here, you can see that we can see the grid lines and stuff, which make it look more aesthetic maybe, and also you can understand it better because you can follow the lines and easily interpret the data. This is how our final result is looking after saving. You can try to understand more about the relationship of rainfall with slope and understand the relation of elements like sediment transport or the amount of discharge moving because of the slope and any other details. So that is it for this video. If you understood this concept, please give this video a like, subscribe to the channel, and share it with friends whom you think this information can be useful.